Hi everyone, my name is Austin Allen, and this is my final project for Geo 471 3D mapping and analysis. So my project, Flood Resilience in Rural Colorado, Analyzing Pathways and Adaptation for Infrastructure Along the South Platte River, focuses on the South Platte River, which runs from the mountains in Colorado down the eastern slope through Denver and out towards Nebraska. And so this area is home to around 80% of the whole state's population, and it's very important for agriculture, domestic use, including drinking water, and recreation. So it's a very important river. And since a lot of infrastructure is centered around it, it can be a very disastrous time if flooding happens. Um, so my focus area is in Orchard, Colorado. We can see from the point on the left in the red, it is in the eastern plains of Colorado, east of Greeley, in between Greeley and Fort Morgan. And the South Platte River runs parallel to the very small town. And this is where I live. So we see the river meandering across, and the study area that I picked was specifically 1.5 miles by 1.5 miles. I was quite ambitious when I actually proposed the project, and I thought it would be, easier to do a large area because I thought that the modeling would be easy, but it turns out that is not the case. And as anything is, it's easier to focus in on a specific area and have a smaller study area. Um, so I also specifically picked this place because not only is it important to me, but it shows all three different types of hazards that are associated with flooding. So we can see from the image on the right, there is a town, and towns are important and at risk of flooding and vulnerability due to population. And we don't want people to die. We don't want people to get flooded in, property damage, all that. As well as we have crops um, and essential infrastructure. So we can see that there is this is Highway 144. It's a very busy highway because there's a state park to the north. So there's a lot of recreation activity. So we see that this line here at the bottom is the current highway. And before there was a highway that ran a little bit more adjacently to this river. And in 2016 and about 2 years later in 2018, there was actually a large flood that washed out the entire road. And I was here at this time, and the only way that I could get to town was to go 30 minutes out east and then go probably like 10 minutes south and then 30 minutes back east again to get 10 miles away from where I was originally located. So disaster and property damage and all that. As well, we can see below this crop circle on the left here, this is actually a dam. Um, it's like an auxiliary pond, so they pump free water that runs down the river into here, and then it's dammed up. So if this area floods, there's also this chance of this dam breaking, and the town of Orchard is at high risk of this. So this is why I picked this study area. Um, so I used data from the USGS, specifically the Eastern Colorado 2018 data. And I actually kind of have a personal connection with this as well. In 2018, this was after all of the flooding. Um, we would notice these like lines of drones just going across the sky. And it was like this for months. And people obviously would be skeptical of this. And we didn't know what this was. And I just figured out what the use of this was when I started my project. I was like, oh, that makes much more sense about what it is. Um, so yeah, just a little caveat on top of it. So that's my study area. So the process that I wanted to do was to see um, how flooding inundation would affect, infrastructure and all that. And this turned out to be way harder than I had thought. I thought that using LiDAR data would be able to, you can kind of like fill it up to a certain elevation and then it kind of fills up from there. But I'll explain how I did this, and it wasn't the most successful. So when I would do this again, yes, and I would take a much different approach. So my first step was creating a LiDAR data set. I would I picked four quadrants um, to represent my study area, and I downloaded these, and then I had a little bit of a trouble to get them into ArcMap to begin with because it's a .laz. So to change this, I had to upload the data into Cloud Compare and then download the data or like save as and then save it as a .las to be able to put it into ArcMap. So this is representing the elevation, and it's quite messy, as there is quite a variation of elevation. But we can see in the top left that there is a high point, and this point, it's quite flat, and then it goes up. This is probably old bankage of the South Platte River at one point. And then we see towards the bottom right, there is a lot lower of an elevation. And if you were there, you would see that. And so this area down to the bottom right is at risk. And this is pasture land down here, actually. And we can see where the old road was, and it's at a higher elevation. And then where that new road is, that's coming down there, it's at a lower elevation. And, they built this newer road back from the river to show, that it can't get washed away. However, as we can see from this, that may or may not be the case if it were to happen again. So also we can see in like the far right that this large swath of dark blue is an agriculture field. So also very susceptible to flooding if that were to happen. And the town is up at a higher elevation and also that bridge. So in 2018, the water actually reached such a height that this bridge was high vulnerability of actually washing away. It was almost up over it. And if you're there if you ever go by it, you'll see that it's actually quite high compared to that. So that's a lot of water. And so, yeah. So my next step was to turn it into DEM. So I did the steps conversion to raster, LAS data set to raster, and I got this. And this is just the base for the next steps that are going to come. Quite simple. So from here, I needed to figure out the direction of the flow of water. And it looks very messy, and it is very messy. However, when you understand what each of the colors are, then it makes a lot more sense. So each of the colors is classified 1 through 128, 1 being east, 2 being southeast, 4 being south, 8 being southwest, 16 west, and so on. So we see this large green section here in the middle. That is flowing east, so it would have the value of 1. So we know that when we do our next data analysis, we know that that water will be going east, as well as this dark red that is flowing northeast. So you can see those colors, and this is actually this graphic, as messy as it is, could be a very good graphic for any type of urban planning, architecture, anything that has to do some sort of site planning. And they want to know how water would flow in a specific area and across the whole swath. So this is actually a very powerful tool as it is. And so, yeah. So after this, I needed to find the stream network. And this is where it started to get a little dicey. So you had to combine the stream or the DEM with the hydrological flow. And we can kind of see that the longer and denser the line, the more flow. So we saw that dark red swath and its line is straight north, and it is dark as well as where that green was. It's also quite dark and a very long line. So areas definitely have stronger flows. And so this is where it kind of um, gets away from the inundation of flooding. This is just would be rainwater. If it was raining a lot, where the water would flow. But that's also is a part of flooding itself. So if especially along the river, if a large amount of water was coming down, it would really like go at those places. So that bridge area is very susceptible to flood damage because of just how much flow is going through there. So the next step was to create flow distance, and this is a very messy map. Um, but you can kind of make out, especially in the bottom area down here, that the flow distance, the longer these channels, the longer the flow. Um, so like this area here, there's quite a large flow, and you can kind of make out the shape of the river. It's quite hard. And this is where the data just kind of like it gets hard. And I would not do this again in this way. But the end result, we do have a little bit of analysis. And so the last step was to use a map algebra and raster calculator it. So I believe it was con, and then we use the distance, and then if it was less than or equal to, and I picked 2. I had tried, oh, this is 2 meters, an elevation of 2 meters. So I had originally tried 3, but it was so messy and it really did not show anything. Basically, it just kind of showed all of the drainage across this whole study area, and that really didn't do much for me. Um, so this 2 meters actually showed a lot more, specifically in the areas that I wanted to originally focus in. So I talk about the bridge, and we can see at the base of this area down here that, this area is vulnerable. And since this is the base of that bridge, that can make infrastructure really weak and all that. And following that old road, and we can see why it isn't the most um, stable, or wasn't the most stable, and why a lot of it washed away. So that is actually a very big observation that we can see here, as well as all of these little dots along the coast, or not the coast, along the riverbanks. And I look at this now and I don't recognize the river from above like this. It has changed a lot of path, and that's because there's not much human development around this area, and so this river can really change. Um, so we can see that in this ag field up in the right area, there is some, um, you know, 2 meter flooding, but that can be good for ag, as long as it is adding nutrients to it. A little bit of flooding in town, but we can see from the lighter of um, the elevation that it is higher up, so we can see that there's not as much darker of a pink. Um, and then we see along this dam here that there is pink, so that could be a vulnerability that we can see of having causing a problem. And then lastly, I didn't point this out before, but I'm gonna point it out now. Down here in the bottom left, there's actually a lot of human development about pumping water, specifically free water. And the suburb of Aurora in Denver has built these here, from their conservation district to pull the free water out to send to Aurora. And that is because they're not getting enough water to begin with. And so they need to outsource it from a place like this. And so we see a lot of pink here, and that is a vulnerability for that water tapping and water pulling activity. So vulnerability there too. So that is my project. even though it didn't go quite as much as I wanted it to, and it didn't show exactly what I had hoped for in the beginning, I do think that I got enough result out of this, and I do think that it shows enough of what I was trying to do in the first place. And yeah, I'm quite happy with what happened, and I'm gonna take this home with me, and the people who have property in these areas or know like hey, like maybe you want to change where you're driving on your land or where, you're putting your irrigation circles. Like, so that's something that can be taken away from this just to help mitigate some of those problems. I know a lot of these lands as well have that are pastures have fencing, and due to the flooding and all that, the ranchers can have a hard time, including my family, actually maintaining these fencing, and that causes a whole slew of problems as well as debris, baggage, and just pollution due to fencing. So there's so many aspects of this area that I felt like it was just, such a good area to focus on because it's just so isolated in its own way and it has so many aspects that come in together that you could apply anywhere. So yeah, and my citations is where I got the lidar data from, and that's the specific one. So thank you for your time, and I hope you enjoyed my presentation. Thank you.